Welcome back to the session again. In today's part of the session, let me continue the second order type of the reaction. Previously, you have learned what is meant by first order type of the reaction, how the first order is derived by the method of the separation of variables. It is similar to that of the first order differential equations and you have obtained the result. That kind of the method we call it as an differential method also. There are different types of the methods used to estimate what is the rate constant as well as the type or the order of the reaction in which any of the decay process or exertion process taking place. With a note of this concept, let us get to understand what about the case of the second order type of the reaction. Okay? Today, let me start the second order type of the reaction in this today's part of the class, and finally, let me move on for stating the first order reaction taking a special consideration especially related to the BOD exertion. As in the case of the wastewater, how the organic matter are present, what is the usage or the significance. Let us get to know it. We shall move on to the second order reaction. The term here, second order type of the reaction, mainly it represents the differential rate equation where the change of concentration with respect to the time is directly proportional to the square of the concentration. If we remove the proportionality, we need to introduce the constant minus k into c square. This is the analysis, or we designate it as R is equal to dc by dt is equal to minus kc square. Now, I want to get to know what is the solution for this particular set of an equation. Similarly, I will not take much time because earlier you have derived what are the set of the equation. Let us recall it. Let us recall it for the zero order dc by dt is equal to constant if it is in terms of n minus k. Therefore, c is equal to c naught minus kt. This is a one case or in sort of an expression that you come across. And if it is in the case of the first order, dc by dt is equal to minus kc, which implies that c is equal to c naught into exponential of minus kt. Getting the point clear for this? Now, when the rate of the change of concentration, it is dc by dt is equal to minus kc square. Therefore, you need to go by the method of separation of variables itself only. Dc by c square is equal to minus k into dt. Again, same principle. At time t is equal to 0, the concentration C will tend to form a C naught, initial concentration. When that which is reaching to T, therefore C will tend to form the concentration C. This is the limit. We need to introduce it when we go for the method of separation of the variables, integrating on both the sides. What happens? Integration of that. So, integral C naught to C of dc by c square is equal to minus k into integral 0 to t dt. So, for this equation, if you know that integral dx by x to the power of n is equal to, now if you take the integral of x to the power of n into dx is equal to x to the power of as 1 by 1. Now, what is the picture here? It is in terms of an x square. that is x to the power minus 2. Apply it here, the same concepts which is simple in nature. Let us get to know what happens here. That is equal to x to the power of minus 2 plus 1 divided by minus 2 plus 1 gives x to the power of minus 1, and this is minus 1. Therefore, it can be taken as minus 1 by x. Minus 1 by x. So, therefore, minus 1 by c within the limit c naught to c is equal to minus k into t minus 0. Now, we have the solution for that. Minus 1 by c plus 1 by c naught is equal to minus kt. Because t minus 0 remains, it is the same thing. I have substituted it, and minus of minus, it becomes a plus here. Look at here at this stage. Therefore, I want to know what is the value of the c. Bring on the k at this 1 by c is equal to 1 by c naught plus kt. Further also you can simplify it, that is not at all a problem. Okay. If you want, you can go for the cross multiplication or whatever else it is required. Therefore, you can utilize this set of an equation. Normally, we go for using this set of an equation, and when the graph is being plotted, what is the representation? Let us get to know the graphical representation of the second order reaction. Normally, in the adsorption process as well as the precipitation process, second order reaction tends to dominate. First order reaction, it is with respect to the decay condition, whereas in the case of the second order reactions, they are much more in the elusive in the case of the rate transfer, maybe in the case of the heterogeneous type of the reaction. There you can go for getting it. Now, for this, what is the graphical representation? Here it is. Instead of passing through that, it will give you the slope. Slope is equal to k, and what is whatever the 1 by c naught, the concentration, and with respect to the time if it is being plotted, then you are going to get this particular set of 1 by c is versus the time if you compute it. So, this particular range will be a 1 by c naught for it, and therefore, you are getting the solution part for this. Understanding it clearly, why the usage of the chemical kinetics is very much necessary. Of course, these are all the simple to know what is the derivations and all, but if you take it in the case of the concentration with respect to the time, there are various set of the plots. Either you can go for the method of excess, the least square method, differential method, as well as even the integral method also. The determination of the kinetics can be governed by the set of the equations, and the governing equations for the second order type of the reaction is this. Similarly, if you have any nth order type of the reactions, maybe dc by dt is equal to minus k into c to the power of n. For a nth order equation, dc by dt is equal to minus k into c to the power of n, that is in, I can take it. For that, we have 1 by c power n minus 1 is equal to 1 by c power n minus 1, that is the c naught whole raised to the power of n minus 1 plus n minus 1 into kt. The general expression which we have come across here, same thing, it is for the nth order reaction. Maybe these conditions will help you for your any competitive exams if you are going at. First order kinetics is essential. Maybe if you are interested for going on for taking up any of the project work also, it mainly depends upon this kinetic condition. But do not think that this First order kinetics, it is simple. It is only for the homogeneous type of the reactions. What about in the case of the heterogeneous type of the reactions? Along with this, you have another variable. Either if I go for adding SD, that is a sediment, or maybe any of the sources or the sinks, that has to be taken for a consideration in solving the differential equations. Hope so you have understood what is the meaning of the kinetic equation for this, okay, and how to provide the solution also. Now, let me derive for the equation exerted by the B body. As in the earlier cases, one of the most important critical category wherever you go, either even for any of the engineering services or sanitation or public health engineering, you need to know what is meant by BOD. The term BOD, what does it represent? Let us get to know. Today, I will go for discussing what is the terminology and what is the method of determination of the BOD. Okay, terminology, and therefore you have the significance also. Earlier, when I mentioned the category of DO, that is the dissolved oxygen. The dissolved oxygen is dependent upon the temperature as well as the sources as well as the sinks also. Whenever you find out where there is a organic matter present in the wastewater, there are biodegradable also, they are non-biodegradable also. Two situation arises and they are combined in nature. It is not easy to analyze it. If you take in the case of the chemical oxygen demand, it is the amount of the oxygen required to oxidize the organic matter under the presence of the dichromatic acidified condition. Okay, under the strong oxidizing or the reducing agent that we come across. Oxidation and reduction process, they are like a parallel type of the reaction that tends to take place. Similarly, here what is meant by the BOD? It is the amount of the oxygen required by the microorganisms to degrade or utilize or to convert the organic matter into the simpler molecular compounds. That kind of the demand exerted by the microorganisms, especially for the biodegradable substances, we call it as a biochemical oxygen demand. The terminology I am explaining, it is biochemical oxygen demand. Biochemical oxygen demand. Oxygen demand means what about the amount of the oxygen that is initially present in the wastewater, and if you take in the case of the rivers or the streams, if you discharge the wastewater containing a BOD or any other organic matter, it tends to mix there. That phenomena we call it as a dilution part of the technique that we go for taking up in the module number 3. Please bear it in the mind, these things are also important. It is completely carried over until the 5th module also. BOD is very much essential. Based upon this, what are the usages and all? Let us get to know in the upcoming classes also. Biochemical oxygen demand, mainly it determines the biodegradable organic matter. Biodegradable organic matter. What are the sources of the biodegradable organic matters? Point to be noted. Sources are mainly arising from the fecal discharge as well as whatever the oils, fats or any other substances contains some amount of the organic matter which are biodegradable, which can be break down by the microorganisms. Similarly, some of the soaps are biodegradable in nature, but not detergents. They are not biodegradable in nature. They have to be degraded in a chemical manner. Similarly, the amalgamation of all those, that is the aggregation of all those organic matter or the constituents which are biodegradable in nature, and how much amount of the oxygen that is required by the microorganisms in order to convert in terms of in simpler compounds in the formation leading to the formation of the carbon dioxide and water, the end products. This is taking place, this process takes place mainly in the aerobic condition, takes place in the aerobic condition. The exertion is also one of the critical factors. We call it as an extrinsic type of the factor. They are the variable in nature. They are the extrinsic type of the factor. They may ask in the multiple choice question, what are the end products of the degradation during the aerobic condition? It is the carbon dioxide and water. For example, if you take the glucose C6H12O6, what happens during the digestion process? In the stomach itself only, exothermic reaction takes place, liberation of the carbon dioxide as well as the water mainly, and other byproducts it is originated, and that byproducts which are originated mainly it consists of some of the hydrocarbon compounds which are simpler in nature. They are required for the energy as well as for the diet also. Similarly, anaerobic means what? The condition previously I have mentioned, formation of the hydrogen sulfide or maybe in the ammonia, and these are the like a byproducts, and the formation of the methane is also one of the principal components during the anaerobic decomposition process. This particular set of the organic matter which tends to decompose by the aid of the microorganisms, we call it as a biochemical oxygen demand. Okay, why it is necessary? Why do you go for biochemical oxygen demand? Directly I can keep the wastewater and then I can degrade it naturally and all. What is the reason? Why you need to recommend all these things and all? They are essentially required in order to know how much amount or the volume of the water to be treated on a daily basis. The wastewater which are arising on a daily basis, can it be prevented on a whole day? No, it is like a 24/7 and it is a continuous in nature. When it is continuous in nature, plan for the proper treatment and the disposal facility has to be taken up by the federal as well as the municipal authorities. If they are not taking up means, they have not planned yet. It is only done only whenever the bottleneck situation comes to picture. We call it as the end of pipe approaches. What is meant by end of pipe approaches? At the bottleneck situation, everything, the concentration and people get to know or talk regarding to the severity condition and then they go for taking the solutions. No, not like that. Previously, you need to plan it, arrive the solution, frame the solution, and then you go for initiating or operating it. That operation and maintenance of the wastewater treatment, designing of the reactors, either it may be a batch reactor or a continuous type of the reactor, or even maybe the stirred tank, moving bed type of the reactor or fluidized bed type of the reactor. That process takes place by any of the following type of the reaction. Keep it in the mind, kindly keep it in the mind. The process or a container or a surrounding system where the reaction is tend to take place, we call it as a reactor. For example, if you take in the cooker where you need to prepare some dishes and all, obviously the reaction takes place. It is also dependent upon the temperature, water, and whatever the external agencies that is required, pressure, everything and all. Similarly, for here also in the wastewater, I want the proper water that has to be circulated or supplied to the people without disturbing its water quality. Thereby, what happens in this particular situation, if I go for letting it out huge number of the toxic waste and all, and even the organic matter and all, it becomes very much difficult. It has a limiting capacity that we call it as a self-purification process. That will take it in the next part of it. Now, let us get to know the methodology of the determination. They are determined by the aid of two methods. One is dilution method, as now I have stated, dilution method, as well as direct method. What is the term dilution method? Normally adopted in the laboratory content, where we need to determine what is the dissolved oxygen concentration at the initial day as well as dissolved oxygen concentration after the final day. Okay? Getting the point clear? Divided by what is the percentage of the dilution taken up. You know, the reason why we need to dilute it means, especially water contains the surplus amount of the oxygen, which is dissolved in nature. If you take in the case of the wastewater, amount of the oxygen which is present is slightly low. Therefore, it may be the presence of either aerobic type of the bacteria or maybe anaerobic type of the bacteria, they might be present. Okay? If they are present, who will tend to dominate? First the aerobic, then the anaerobic condition prevails. It develops on the later stages. Thereby, with the presence of this, we need to go for the dilution process. What is the dilution? Normally it is adopted by the Winkler's method of determining the dilution method. What is the term dilution method? If they are taking it as like 1%, 2%, 3%, they are mainly executed in order to determine what is the strength of the wastewater. Strength of wastewater. Whether they are low in nature or maybe a medium strength type of the wastewater, or strength is very high. The strength can be determined by the aid of knowing what is the BOD content, that is amount of the organic matter oxidized by the microorganisms. If I give only the less amount of the oxygen and incubate it at a constant temperature, is it possible to do it? Question arises like this. Therefore, here dilution method is a simple process where you take ample amount of the wastewater and dissolve it in the water which is aerated in nature. Okay, which is aerated in nature. They are normally conducted with a procedure known as the Winkler's method. The Winkler's method of determination of the DO, iodometric method. Okay, getting the point clear? What happens? You need to determine the execution of the dissolved oxygen, because BOD is the basis to determine the strength of the wastewater, means then DO has to be present. DO serves as a test for the BOD. How it is? DO of the initial day you take it, and DO of the final day you take it, subtract it, what is the concentration? Example I would like to give, 7.8 is mg per liter is the initial DO concentration, and the final DO concentration is said to be 1.2 mg per liter. I have taken the dilution factor as a 1%. Therefore, the BOD can be determined as dissolved oxygen concentration of the initial and dissolved oxygen concentration of the final divided by percentage of the dilution. This particular thing we call it as unseeded condition. Unseeded condition. Taking 1 ml in 300 ml of BOD bottle sample. One percent of the 300 ml, or maybe it may be lesser than that also, 0.3 or something. 1% of the 300 ml means how much it is, leading to 3 ml in 300 ml, like that. We call it as a, there are various dilution methods. If it is strong means we take it as 0.5, 1, 1.5, 2, 2.53, like this, so on. We go for it. And the determination of the BOD, for example, 7.8 minus 1.2, dilution factor is taken as in terms of in percentage, that is 0.01. How much it is? 7.8 minus 1.2, it tends to give you 660 mg per liter. Okay. So, initial dissolved oxygen concentration which was present earlier during the initial phase of the condition of the BOD, and after the final day. How are you going to compute the final day? Here comes the one of the most salient features. It is mainly dependent upon the first order kinetics. Okay, how you need to determine all those things I will cover up in the later words. 660 mg per liter, getting to know this concentration. Similarly, there is another set of the condition where the principles are based on the Winkler's method that you go for study in the laboratory. But generally, I will tell you what are the procedures. You need to take a BOD bottle, take 3 ml of the sample if it is in the case of the dilution of the 1% of the 300 ml, and pipette out 3 ml, and finally you fill the whole BOD bottle with aerated water and stopper it and invert it. Next step, what happens? Open the stopper, add 2 ml of manganese sulfate plus 2 ml of alkali iodide azide in that condition. If the precipitation tend to occurs, that is white precipitate, then it states that the DO content is absent. If at all, if brown color precipitate appears, therefore the DO content is present. Further, you need to add 2 ml of concentrated sulfuric acid. After adding the 2 ml of concentrated sulfuric acid, whatever the cloud formation or the precipitation reaction taking place will tend to reduce it, leading to the formation of the golden brown, yellow or ish in nature, that is a color. Then subjected for the titration by using sodium thiosulfate as a titrant, okay, in the titration process taken in the burette, and the titrant which contains the organic matter or the sample which is diluted, only taking 203 ml of the sample. The reason why we need to take 203 ml of the sample, especially for the BOD, earlier what I have stated, 2 ml of alkali iodide plus 2 ml of manganese sulfate were earlier utilized. If you deduct those two in order to determine whether the DO is present or absent in the given sample, that you need to deduct it. Therefore, the normality of the solution is tending to change also, whether you take in the case of the sodium thiosulfate. And here mainly 300 volume of sample that has to be taken into the conical flask, it is 203 ml of sample. The reason here, it mainly dependent upon the 200 ml of the sample which is normally taken, out of the 300 ml, and in order to determine whether the DO is present or not, getting in the form of 203 ml of the sample. This is how you need to take it. Remember, this is very much important while considering the dilution factors, allocating the reason why we need to take the 203 ml of the sample. What is the reason for the BOD and all? We'll get to know. Understanding this, coming back here, this is for the unseeded condition. Seeded condition means we have the blank. What is meant by the blank? Whatever the DO concentration present in the blank means take the aerated water sample, pour it into the BOD bottle completely, 100% of the aerated sample, take another BOD bottle, okay, you also fill it. There are two sets, or we call it as a two pairs. One pair is related to the dilution portion of the sample, another it is the blank. Therefore, the combination of the diluted portion as well as the blank will tend to give up what is the BOD of the seeded sample. Normally, this kind of the seeding process where the microorganisms are completely absent is occurring in the case of the industrial wastewater, where the microorganisms are lesser in nature, except in the case of the food industry. If you take any the tannery or leather and all, chemicals are more, but the BOD is present if it is in the anaerobic condition. Thereby, in order to increase the activity of the biological degradation, what you need to do, it is mainly go for the dilution through the seeded. So, normally the BOD, it is mainly designated to use or incubated at 20 degrees centigrade. Why at the 20 degrees centigrade? It is an optimal condition where the growth of the microorganisms takes place. And for the tropical countries, mainly Streeter-Phelps equation, when you come across in the model number 3, in the determination of the BOD, there are different methods. We call it as a respirometric type of the method, either the electrometric type of the method. These are the different methods that are utilized for estimation of the BOD. One of the method generally or widely followed is the APHA method of Frinkler's method of determination of the dissolved oxygen concentration. Coming back to that, you titrate it by using a starch as an indicator, because starch is an organic indicator, and continue the titration. It turns, the titration process has to proceed till the golden brown color tends to fade away. We call it as a pale yellow color, and then add 2 ml of maybe or a 1 ml of the starch as an indicator. Then later what happens? It turns into blue color. The iodide has to convert it in terms of an iodine. The process of the liberation of the iodine is determined by the equivalent weight of the oxygen that is present in the given sample. Hence, we call it as an iodometric method of estimation. Directly you can come for it. Okay, this is the set of the procedure. Now, let me get to know what are the significance of BOD. I have come across by stating the dilution method of the principles. You can also go for D1 minus D2, minus of, that is taking the DO of the blank as well as the DO of the sample, both at the initial day as well as the final day itself only. Then we come across the case of the seeded type of the sample. Same thing here, it is DO of the blank, DO of initial as well as DO final of the blank, minus of DO of the sample initial and DO of the sample final, divided by what is the percentage of the dilution that you have taken. This is an example for determining the seeded condition. Okay, seeded condition. Normally in the seeded condition, the DO will be quietly not varying much. If you take DO in the case of the wastewater which you have diluted it, there you will go in. Okay, ds minus d of the final minus of that content will be divided by the P. We are going to get the value. Similarly, there are two types of the exertion. If you take in the case of the direct method, I can able to determine what is a BOD by going through the first order differential equation. How it is stated, let us get. If I consider the initial concentration normally BOD is denoted by L here. Okay. How much days is required for consuming the organic matter? Normally, it is impossible to determine the rate of oxygen consumption, but by the sort of the expression we can able to determine either the 5th day or 20th day type of the BOD, because in theoretical basis if you consider it, it is equivalent to that infinity. That means what is the ultimate BOD that is present in the given sample, what is the time that is required for degradation or conversion into the stable organic matter. Okay, unstable to the stable situation it has to lead. Therefore, the rate of reaction is given by dl by dt, normally where L represents the BOD concentration. The BOD with respect to the time is mainly equivalent to that of is equal to minus K, and D it represents and L. What is the term D represents? Earlier I have stated what is the graphical representation. If it is in terms of a minus Kc, you have an exponential decreasing function where C will tend to vary in an exponential manner where f of x is equal to e power minus x. Similarly, if f of x is equal to e power x, then what happens? The concentration will tend to be in a stable. That means what is the oxygen required? BOD, how much is the time remaining conversion of an organic matter, and how much is the amount of the oxygen being exerted if you take the condition either with respect to the distance or with respect to the time, how does it vary? The concentration, how does it vary? This particular sort of an expression is most important. We have an L naught, an initial concentration with respect to the time. At the time t, L naught is equal to how, and Yt it represents the BOD of the 5th day. Normally, wherever you go, the expression it is given by either BOD 5 day BOD we call it as. Okay, 5 day BOD. Why 5 day BOD is important? It is converting whatever the organic matter into the simple organic matter forms. Okay, as I have told that the output products as CO2 as well as H2O, that is the carbon dioxide in the water. In the 60, if that is in the 5th day, 68% of the organic matter is covered up, that is degraded. Hence, at the 20th day, what is that? You can go for estimating that it by using the following expression. So, dl by dt is equal to minus kd into L, where kd it represents the deoxygenation coefficient. Why? What is the reason? Deoxygenation mainly it takes place if at all, if the concentration of the substance, if you consider in the case of the rivers and all, I will explain it. For time being you get to know. Whenever there is a discharge of an effluent, the oxygen content will be there for one particular period of the time, and slowly it starts degrading due to the utilization of the oxygen by the aerobic bacteria. the organic matters are started to convert it. Okay? The product of conversion will tend to increase in an exponential manner and leads to one stage. We call it as a carbonaceous stage. There is another stage, we call it as nitrogenous stage, that I will take up in the next part of the class. For time being, when you come across what is the L naught with respect to the time t, so therefore here there is an exponential decreasing function, it tends to come across like this. What about the BOD exerted? Again, BOD exerted, it is the time which is being remaining in this particular sense. Okay, like this you have. Similarly, this particular field we call it as a BOD exerted, YT. Now I have an expression for this, and what about the other situations or the cases? If I know that dC by dt is equal to minus kc, similarly, you know the expression, go for an integration method. At time t is equal to t0, c will be equal to c naught. Time t is equal to t, c will be equal to normal c. Similarly, here also when time t is equal to 0, L is equal to L naught. When time t is equal to t, L is equal to LT or L, like that. Okay. Similarly, we have the solution, that is L is equal to L naught into e to the power of minus kd into t. If you want derivation, go back to this, substitute it, you can get it. There is an assignment for you people. Do it, you get to know it. And whatever the BOD that is remaining, I know that how much amount of the organic matter which was present in the earlier, maybe at 600 ml or 660 ml, maybe the initial BOD, the BOD after the 5 days. What is the initial day of the BOD? I don't know. I need to get to know what is that initial day of the BOD. That's why I need to know how much it is. What happens? Initial BOD tends to decrease over the period of the time. And meanwhile, the organic matter, that is oxygen exerted, it is being increasing on over the time in an exponential manner. Thereby, YT we call it as, or YT is equal to L naught, the ultimate BOD, minus the BOD at that particular instance of the time, L naught minus L. Thereby, this call it as equation number 1, call this as equation number 2. That is the rate of formation minus rate of reaction, like that it is. Formation of the reactants and the products formation. When I know this set of an expression, out of L naught, I get to know what is the value of the YT. L naught I know, and what is this exerted? That is L naught minus L. So this is L, it becomes. Okay, the concentration decreases. So L naught minus L, it tends to give me the YT. Therefore, L naught minus, what is an expression? L naught into exponential of minus kd into t. Therefore, YT is equal to, L naught is a common factor, therefore 1 minus e power minus kd into t. This particular expression we go for utilizing in the case of the problems. Getting the point clear? This particular expression is exerted in the case of the biochemical oxygen demand. Normally, this set of the questions are asked in the IAS GATE exams also, as well as even in the KPSC exams. Please do remember the formula, and you need to remember in the third module also, because we are going for the dilution factor consideration. How does it tends to vary? Okay, this is an expression normally we go for getting for the BOD consideration. 600 mg per liter initially. For the time t is equal to, at that particular day, how much I need to compute it. This is related to the practical aspects of the numerical problems. Getting the point clear for this? I hope so. Let me revise it once again. Biochemical oxygen demand is the amount of the oxygen required by the microorganisms to convert the organic matter into the simpler compounds. Similarly, here the biochemical oxygen demand, there are two types. One is the carbonaceous BOD, carbonaceous biochemical oxygen demand. The nitrogenous content which are present, we call it as a nitrogenous biochemical oxygen demand. Therefore, we have a two set of inequations. Instead of KDL, we have KNL, okay, or KN into LN. That is nitrogenous BOD. The first stage we call it as a carbonaceous BOD. The next stage that is preceding, we call it as a nitrogenous type of an BOD. That is mainly important in the case of the nitrification and denitrification, phosphate removal, advanced oxidation process that takes place. This set of an oxidation by the microorganisms of the organic matter taking place are mainly due to the two set of an organisms. And I have given the method, dilution method, where you need to use the aerated water. What is meant by aerated water? Process of adding the oxygen into the water. That water is utilized for making the proper dilution. Otherwise, you will not get the value. There is a major procedure involved. And taking the methodology, either you go for unseeded or maybe the seeded procedure, getting for the initial concentration and the final concentration, you get to know. Normally, 5-day BOD, it is represented as Wi-Fi. Wi-Fi. Okay. This set of conditions, if you need to determine it, is mainly dependent upon the exertion. How does it takes place? Okay. And this condition will tend to prevail where the BOD concentration is less, and the BOD concentration tend to reduce here if you take it on for a time basis itself only. Okay, if you plot the slope, you will get it. That is ln of C by C naught versus of T. You have the least squares method, you can get to know how does it changes. You get the regression coefficient also. You can do it in the Excel plot. And we have another method for the determination of the BOD. We call it as a Fujimoto method for the determination of the BOD. And if I wanted to get the concentration like a 32 mg per liter, 10 or 5 mg per liter, what is the condition? So, I know what is L and I know what is L naught also. Therefore, I need to know what is the time t, how much time it has taken, how many days it has taken. Normally, this is expressed in terms of an per day. Okay, per day this is expressed. And if you take in the case of the kinetic coefficients, you need to be very much careful regarding to those issues. Second order reaction is represented in terms of an moles per second, okay, or the concentration of whatever it is taken. Okay. Now I think you have got to know what is the stages of the BOD, how it has to decay, and what is the oxygen exerted. Okay, both the conditions. That's why mathematical representation is very much important for this. Based upon this itself only, you have the designing features or the considerations, oxidation points if you require, aeration process if you require, how much amount of the oxygen is required, or what are the different methods that are processed up. These are the things that you need to get to know. Okay, hope so. I think you have got to know what are the different set of the things. If you have any doubts, you can get to clarify it. Okay. If I don't know what is the distance, therefore we have another set of the conditions. So L is equal to, can also be represented as if time t is equal to distance by velocity. This is especially for the case of the rivers. So L is equal to L naught into e to the power of minus k d into x by u. This kind of the reactions can be determined in the case of the rivers, canals and streams. Okay, know all those pictures and all, get to know. Okay, hope so you have understood the concepts clearly. I have made a simplified part itself only. Please do read this. It is a very much important. I am going to ask it in the examinations also. Keep it in the mind, and in the next set of the class we shall discuss more regarding what are the limitations of the BOD test, what are the significance of the BOD test. Today I have mentioned only the terminology and the method of the determination, and how to estimate the BOD content. We shall take some of the numerical problems and solve it. Till then, stay tuned for it. Kindly look upon for the previous sort of the videos also. If you are not subscribed our channel, please do subscribe it, and thank you one and all.